So till now we have implemented binary search tree, and this particular tree, it can add nodes and then it can do various traversals. Now let's add the search functionality to this binary search tree. So we will say that we are going to have a search value function, and this will take an integer value as input, and then it will return a pointer to node that contains that value. If value is present in multiple nodes in the tree, we will return value to one of the nodes. Okay, so we are saying that search value is a function that takes as input integer and returns pointer to a node that contains that value. So now let's go and implement this function. So entry node pointer in bst1 search value and integer val. Okay, and now what we have to do. Okay, so let's remind ourselves of the search algorithm that we wrote. Okay, so we say that if you want to search for a value starting from a node, first you ask question if your node is null. If it is null, then you return the node, or if the value is present in the node, you still return. Okay, so let's do this first base case in our code. So just like what we did for traversals, we have the public function where a user needs to specify only the value to be searched, but internally we will have a private function which would be search entry, which will take in the value and from where to search. Okay, so we have to go back and add a private function just like what we did for traversals. Okay, so I will say that there is a function that returns pointer to a node, and the name of the function is search in tree, and it takes input as integer value and pointer to a node. So now let's go and do it. Let's implement our function. Search in tree, and we have integer value to search and pointer, and we are pointing to a node pointer. Fine. So first question we have to ask is if the node that is given to us equal to null pointer. In that case, we are going to return null pointer. Second thing is if the value that we are searching for is equal to the value that is stored in the current node. So node pointer, I do the get data. If both these values are equal, it means that I have found the value. In that case, I would return the pointer to the node. However, if it is not present, then we have to ask question where should we search. Okay, and where should we search? So now we are going to compare our search value with the node data, and if it is less than or equal to, we are going to search in the left. Otherwise, we are going to search in the right. So let's do it. So now if we compare our value and it is less than or equal to our node pointer dot get data, in that case I'll say search in left, else we have to search in right. So to search in left, what should we do? We should call function search in tree with the same value val, but now we should look at node pointer and we should get the left child and we should search in the left, and similarly search in right will be instead of left I have to get the right child. Okay, so that's our function for searching. Okay, so let's compile it. So now let's compile it, and then there are some warnings. Okay, so first thing is that we should return the result of this search. So I would say return the result of searching in the left. Similarly, return the result of searching in the right. Okay, so that should reduce the warnings. Okay, so now what we should do, the same thing here, we should return the result of searching in tree, and that should take away all the warnings. Let's see. So all the warnings are taken care of. So let's go to our main and actually call this function. Okay, so so now we have inserted 1 2 3 4 values in our tree, and let's search for value 5. Okay, so now what I'm going to do is let's say that n1 is equal to tree dot search value. I'm going to give value 5, and when I receive the result, what I will do is I'll just print the contents of n1. Okay, so I'll just say that data in n1 is, and we will expect that the value should be 5. Okay, so let's build this and then run this. Okay, so I'll go and run the binary search.exe, and we get the result that data in n1 is 5. Okay, and then let's try to search a value which is not present. So if I search for 9, the n1 would be null, right? So then let's add if block here. If n1 not equal to null pointer, then we will say that let's access the data and print it. Otherwise, we'll say that value not found in data. Okay. So now when I search for 9, I expect that it should not be found in the data. Let's see. Okay, and we get value not found in data. Okay, so that's how we can do search in. Oh, did I show you? Yes. So that's how we can do the search in binary search tree. The recursive logic is pretty straightforward. You start from root and then you keep on searching till you either reach a null pointer or you find the required node.